Our next subject in organic molecules is how do we name molecules that are a little more complicated than our simple alkanes, the pentane, the hexane, the heptane, and things like that. Well, the first thing we have to know is that there's two parts to an organic molecule. There's what we call the backbone, which is the longest carbon chain in the molecule. So if I drew pentane like that, my backbone is pentane. I can find 5 carbons in a row. And even if I start to put things sitting off of the pentane, the 5 in a row is still the best I can do. I can do 1, 2, 3, 4, and 5. But even though there's a 6th carbon, I can't get that into a row. And so here my backbone is still pentane. In fact, I can even add something else sitting off of there. And my backbone is still pentane, because now there's 7 carbons, but still the longest chain is 5. In fact, I could even add another thing on there. And I've added carbons now, and I have 8 carbons, but still my backbone is pentane, because even if I went in a different direction, let me do this in a different color, 1, 2, 3, 4, and 5, I can do 5 in a different direction, but 5 is still my longest, and so pentane is still my backbone. And then the other part is the substituents. And that's anything other than hydrogen. That sticks off of the backbone. So what do we mean anything other than hydrogen that sticks off the backbone? Let's say I decided that this green backbone that I had 1, 2, 3, 4, and 5 on was my backbone. We know on this number 1 that there's 3 hydrogens sitting off there because there's only 1 bond drawn. But those aren't substituents. Those are just the hydrogens that are part of our backbone. But right here, what do we have? We have on carbon number 3, something sticking off of carbon number 3 that's not hydrogen. In fact, it's made up of 2 carbon atoms, right? And this one's actually a CH3, and this one's a CH2. And so we've got CH2, CH3 sticking off of our backbone, and that's what we call a substituent. We have another substituent here that's a CH3 group sticking off of carbon number 4. And so those are the 2 substituents in this molecule that has a backbone of pentane. And that's how we're going to start naming these things, is we're going to name substituents where they are and also name our backbone. Substituents have a name. If I've got a CH3 sticking off, well, 1 carbon we had the meth prefix for, methane, when we were talking about the alkanes. When it's a substituent, we use the YL, and we call it a methyl group. Over here, we had a CH2, CH3 sticking off, and I'm using those condensed formulas right now. This dash that I'm going to put in front of it means it's attached to something there. There's a bond there that we're not drawing. When we had 2 carbons, we called it ethane. So it's got the eth, but now it's going to be ethyl to say that it's a group. It's a substituent on a molecule. If we get a little bit bigger, CH2, CH2, CH3. When we had 3 carbons, we called it propane. And so this is going to be a propyl. But it turns out there's 2 different ways to attach something that's a propyl. So let me draw 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I've got 2 heptanes here. One, I'm going to draw 1, 2, 3. I've got 3 carbons sticking off my main backbone. 1, 2, 3, 4, 5, 6, 7. And so that would be a propyl group. So we've got a propyl group sticking off of our backbone there. But it turns out you can also draw, instead of attaching it to the end carbon of your 3 carbons, you can attach it to the middle carbon of your 3 carbons. I still have 1, 2, 3 carbons sticking off there, but I'm now attached to the middle carbon instead of the end carbon, and that actually is different chemistry-wise. When you're attached to the middle, you call it an isopropyl. Isopropyl, you may have heard that before. Isopropyl alcohol is the alcohol you're going to find in your medicine cabinet. And the iso just means middle. And so isopropyl alcohol means there's an alcohol in the middle. Propyl means 3. And so isopropyl alcohol looks something like that because an OH group is what makes an alcohol. So we've got an isopropyl group there. So those are the 3 substituents that we need to know in terms of hydrocarbons. We need to know methyl group, ethyl group, propyl group, and isopropyl group. There are butyl groups and other things like that, but we're not going to go that far in this class. So let's name some molecules that have these substituents in them. And so how do we name these molecules? Well, the first thing we always need to do is we need to find our backbone. And what is the backbone? It's the longest carbon chain that you can find. So I could do 1, 2, 3, and 4, and 5. So I get 5 there. If I numbered in a different way, let's say in orange here, I could go 1, 2, 3, 4, and 5. No matter what I do, I'm going to get 5 things. So my backbone here is going to be some sort of pentane. 2. We need to figure out where to start numbering. So I'm going to erase these orange ones here. And when I did my pentane there, I went from left to right, but I could have done right to left. I could have called this 1, 2, 3, 4, and 5. And there's really no difference in that. But how do we know where to start our numbering? We're going to use this numbering to tell someone that we've got this group sitting on a specific carbon as opposed to a different carbon. So how do we know where to start that numbering? Well, it turns out our rule is we want the first substituent. And what's a substituent? Something sticking off of the main chain. This is a substituent because we drew our main chain as this guy, and he is sticking off of that one. We want our first substituent to have the lowest possible number. If I use my green numbers up here, my first substituent is going to be this guy, and he's going to be on number 2. If I use the purple numbers, my first substituent, and only substituent in this case, is going to be on this one, and he's going to be number 4. And so in this case, the green actually wins because it gets us a lower number. So green wins. Now, the next thing we're going to do is we are going to list each substituent with the carbon number. So up here in my molecule, I've got nothing attached to number 1. We're looking at the greens now, so let me even erase the purples. We're looking at the greens now. I've got nothing attached to number 1 other than some hydrogens. Those aren't substituents. But to number 2, I've got this thing sticking off. And what is it? It's a carbon with 3 hydrogens. And if you remember, CH3 is called methyl. And so I'm going to say, hey, I've got a methyl group here. And specifically, I want to say it's on carbon number 2. If I keep going forward, there's nothing on carbon number 3, nothing on carbon number 4, nothing on carbon number 5. And so I only have this 1 together. And then we're going to put everything together with dashes. And what do I mean by that? Is at the beginning part of the naming, and anytime there might be a space, we're going to use a dash instead. So we're going to tell someone on carbon number 2 dash, I'm going to put a methyl group. I start with my substituents, and then I end with my backbone name. In this case, it was a pentane. And you'll notice there's no space between methyl and pentane. And there's a dash here between the 2 and the methyl. How you say this one out loud is you just say 2-methylpentane. You don't say the dash, and you kind of say it quickly so you sound smart. Oh yes, I've got some 2-methylpentane. And that's how we would name this molecule. And any chemist who knows what they're talking about could hear that and draw that molecule in less than 2 seconds. And you'll be able to do that not too long from now as well. You get pretty good at this stuff with just a little bit of practice. Let's name something else. Here we've got a molecule, And it's a little more complicated looking than the last one. But remember, in our skeletal structure, we can always expand on things if we want to. And the author of this particular structure wanted to expand all those end CH3 groups just to try to emphasize them. But our rules are still the same. We're going to find the longest chain. We're going to start numbering so we get the lowest first substituent. And we're going to label each substituent and then put them together with dashes. So how do we start numbering? Well, you just kind of got to go through the molecule and find different ways. I usually start with just going left to right and see what I get. 1, 2, 3, 4, and 5. So I get 5 if I go that way. If I take a different path, I get 1, 2, 3, 4, 5. If I take that green path, so that's pretty much the same. If I take a 1, 2, 3, 4, 5, that's 5. In this class, it doesn't matter which path you take. Okay, there are rules for which is the best path. We're not going to talk about those. It doesn't matter which path you take. If you take a path that gets you your longest chain and name it that way, you'll be just fine. So I'm just going to go to the left to right one here because they're the one going up, down, across the middle, because that's usually the easiest. Now I've got to decide, am I going to name it using the green numbers that I have right here, or am I going to name it using the other direction? So let me blow this guy up for you a little bit. And if I can, I'm going to number 1, 2, 3, 4, and 5. I could number from the left. I could number from the right. And what am I going to do? Well, what are my substituents? Right? This is my backbone. So anything sticking off my backbone are substituents. So there's my 2 substituents. If I go with the green numbering, my first substituent occurs here at carbon number 3. If I go with the orange numbering, my first substituent occurs here at number 2. I want the lowest possible number, so orange wins in this case. And I'm going to go with orange. So what do I need to do next? What do I need to do next? I need to list all of my substituents. So I just go through my molecule and I count, and I look at each atom and see if there's anything attached to it. On carbon number 1 here, if orange wins, there's no substituents. There's hydrogens, but there are no substituents. On carbon number 2, there is a substituent. There's a CH3 group sticking off there. And so I've got a 2-methyl, just like that. On carbon number 3, there is another thing going on there. And what is that? Is it a methyl? Well, it's not, because it actually has 2 carbons. It's got 1 here and 1 here. And when we have 2 carbons, if you remember, that was an ethyl group. So we've got 2-methyl, we've got 3-ethyl. And then there's nothing on number 4 other than hydrogen. There's nothing on number 5 other than hydrogen. And so we've just got a 2-methyl and 3-ethyl. Our backbone had 5 carbons, so it's some sort of pentane. Now we have to decide, how are we going to put this together? Are we going to call it 2-methyl 3-ethyl, or are we going to call it 3-ethyl 2-methyl? And it turns out when we're putting them together, we're going to go not numerically, but we're going to go alphabetically. I didn't make up these rules. If I made up the rules, I would have gone numerically, but I'm sure there's a good reason that we don't. So we're not going to say 2-methyl first. We're going to say 3-ethyl first, because ethyl comes first in the alphabet. So 3-ethyl, and then some more dashes, 2-methyl, and then we put our backbone name on the end there, and we get 3-ethyl 2-methyl pentane. And that is the name of this molecule up here. And again, say it really quickly so you sound smart. 3-ethyl 2-methyl pentane. Let's name this one. It's gotten a little bit bigger, isn't it? But the process is exactly the same. We're going to find our backbone, figure out which way to number, get our substituents down, and then put it all together. Okay. So what's our biggest backbone? 1, 2, 3. Well, actually, let me number them for you. 1, 2, 3, 4, 5, 6, 7. And no matter what you do, you're not going to get better than 7 if you go around in a circle on that bottom one. But we have to decide which way we're going to number it. 1, 2, 3, 4, 5, 6, and 7. Orange or blue in this case? Well, if we go with orange, our first substituent occurs here at number 2. If we go with blue, our first substituent doesn't occur here till number 5. We want the lowest possible number. So in this case, orange wins again, because it's got the lowest possible number for the first substituent. I'm going to list all my substituents. 2 has a methyl group right there. And what do we call this one that's attached to number 3? Number 3, it's got 1, 2, 3 carbons on it, but it's attached via the middle carbon. 3 carbons attached by the middle carbon. What did we call that? We called that an isopropyl group. And so we have a 2-methyl and we have a 3-isopropyl. Now, our 7 here for our backbone, what is that? That's some sort of heptane. And so we know that's what we need to put together. How are we going to know what? Do we put 2-methyl or 3-isopropyl first? Alphabetical, I comes before M. And so we call this 3-isopropyl. Oops, propyl dash 2-methyl heptane. 3-isopropyl 2-methyl heptane. And that is how we name this big molecule up there. Turns out carbons aren't the only thing we can put on hydrocarbons. We can put other things. We're only going to focus on how do we name things that contain halogens, but obviously there's rules for naming things that contain just about anything that you want to do. But here we have halogen. Remember, halogens are fluorine, chlorine, bromine, iodine. And when we have the halogens sticking off, and they are substituents because they're attached to our main chain, but they are not hydrogen, which makes them substituents, they end up with an O at the end of them. And we call this a bromo group. If we had chlorine, we'd call it a chloro group. If we had fluorine, we'd call it a fluoro group. And my favorite is iodine. We'd call it an iodo group. Right? So that's what we do when we've got these substituents on the end here. I'm going to erase these guys because we don't need them for now. We know we've got a bromo group, and so we're going to do that one for now. So everything else remains exactly the same. We find our longest backbone, we number, we list, and then we put together. So what's the longest backbone in this case? It's very tempting for people to say, well, I've got 1, 2, 3, 4, and 5 carbons, and so I've got some sort of pentane. But remember, this bromine, as soon as we put it on there, it's no longer a carbon. And a backbone is the longest carbon chain. So we can't start counting at number 1 on the bromine. We have to start counting from the first carbon, which is like this, 1, 2, 3, 4. Now, you'll notice no matter which way we go, starting from the bottom, moving back, we're not going to get any shorter than, or any longer than 4. And so that is our backbone. And now we have got to decide, do we name it, or sorry, do we number it starting from the left or starting from the right? If we name it in red, our first substituent comes at number 2. If we name it in blue, it looks like our first substituent comes at number 3 there. But you have to be really careful, especially with these halogens. When they're sticking off the end there, they're attached to number 1, and they're not hydrogen. So here we have a substituent on number 1. And so in this case, my blue, or is that purple? My purple numbering wins because we've got a bromo at number 1. So we're going to list these guys. We've got 1 bromo, nothing on number 2. On number 3, we've got a methyl. And 4 things, it's going to be some sort of butane. How do we put those together? The bromo in this case is first because it comes first alphabetically. And we say 1 bromo, 3 methyl butane. And so 1 bromo, 3 methyl butane is what we'd name this molecule. All right, just a few more examples so we can kind of get all the details of how this goes. This molecule is a little small, so let me blow it up for you. Again, the author of this one is emphasizing all those CH3 groups on the end. You don't have to. You could draw this exact same thing just by not including all these little CH3s, and it would be exactly the same molecule. We're going to do the same things. Find the longest chain, number, list, put together. 1, 2, 3, and 4. No matter what I do, I'm not going to be able to get more than 4. Whether you go around like this, whether you start from up here, doesn't matter. You're not going to be able to get more than 4. But then we have to decide 1, 2, 3, and 4. Do we label with the red on top or the orange on bottom? Red on top, our first substituents occur at number 2. Orange on bottom, our first substituent occurs at number 2. We've got a tie. Ow, how? Sorry, I banged my arm on the table over here. How do we figure out a tie? Well, we figure out a tie just like we figure out order, alphabetical. In my case of red here, I have a bromo group and a methyl group at number 2. In the case of orange, I have a methyl group at number 2. Because bromo occurs before methyl in the alphabet, I would like my number 2 to have bromo on it rather than my number 2 to have methyl on it. So I'm going to break that tie alphabetically. And so 4 things, we know it's going to be some sort of butane. And then we're going to start listing things. So we decided that red wins because then we get number 2 as bromo. And so we say 2 has got a bromo. Now, we have a case in this one where there's a second thing on number 2, right? The chain goes through number 2, but there's something on top of it, and there's something below it. And so we have 2 substituents on number 2, and that's just fine. Our second one is methyl, because it's a CH3 group sticking off. We also have number 3, another methyl group, and that's the one that's already circled in orange there, and there's nothing on number 5. So now how do we put those together? Again, alphabetically. And so we say 2-bromo. And what are we going to do with those methyls? I'm going to do it incorrectly first, so don't copy this down yet. You might be tempted to write 2-methyl, 3-methyl, and then write your butane, but it's a lot of work to write, and so we don't do that. What we do is we put them together, and we say 2-bromo, and we say 2, 3. There's 1 at number 2, and there's 1 at number 3. But we also have to say in the name that there's 2 here. So 2,3-dimethyl butane. And there is no space between the methyl and butane, even though it kind of looks like one the way I wrote it. So 2-bromo, 2,3-dimethyl butane. When we say it out loud, we don't say the dashes, and we don't say the comma. We don't say 2, 3. So 2-bromo, 2,3-dimethyl butane is how you name this molecule up on top there. How about this one? What is this one going to be? Well, let's figure that out. Longest chain, where to start numbering, list them, put them together. 1, 2, 3, 4, 5. Orange, or 1, 2, 3, 4, 5. Green. In any case, we know it's going to be some sort of pentane. If we go with orange, we get bromos at number 2. If we go with green, we get methyl at number 2. We want those bromos there. So we've got some sort of pentane. We're going to list it. We've got 2-bromo. But that takes care of this one. But we also need to take care of that one. So I'm going to list it again. So I've got 2 bromines, so I've got to list bromine twice. Nothing on number 3. On number 4, there's a methyl group. So now we've got everything. Nothing on number 5. There was nothing on number 1. We got to put those together. Going to put them together alphabetically. So how do we do it? Do we just say 2-bromo? Well, if we say 2-bromo, that doesn't tell someone that there's 2 bromines on that one, right? It would just imply that we have 1. So what we're going to do is we're going to number both of them. They say on number 2 and on number 2, there are 2 bromines. 2,2-dibromo, 4-methyl, and then it was a pentane, and so we end with that. And that molecule is named 2,2-dibromo, 4-methylpentane. If I told this to you 20 minutes ago, you would have panicked, but now you're doing okay. Maybe not perfect, but doing okay, because This system is very systematic. It makes sense once you learn it, and you learn it by practicing it. What about for cyclic compounds? How do we name cyclic compounds? Well, it turns out the rules are exactly the same, but you have a little more flexibility in a cyclic compound, as we'll see in a moment. But the first rule you need to know for this class, for cyclic compounds, this rule is important enough that I'm writing it down. The ring is the backbone. There's not a separate ring. Even if you can count around and find a longer chain that's longer than the ring, you don't do it. Whatever your ring is, that is the backbone. Whatever is sticking off that ring is a substituent. Doesn't matter if you can make something longer by doing it another way. The ring is the backbone. And so my ring here is a cyclopentane. And so I know I have some sort of cyclopentane as my backbone. But then I got to figure out, how do I number this thing? And we know with numbering we can do one way or another way. Where do we start, though? It's a ring. Well, we always want to start a ring by putting things right on a substituent. Why? Because the rule is we want the lowest possible number for a substituent. If I put a 1 here and a 2 here, then I'm getting a number 2 for my substituent, when I can just as easily put a 1 here and a 2 here, and then I get a 1 for my substituent. But then the question becomes, do I put the 1 here on the bromine, or do I put the 1 here on this other group? And if you remember, anytime there's a tie in organic chemistry, we break it by doing alphabetical. And so I'm going to put a 1 on the bromine instead of on this guy down here. If you know this guy, there's 1 carbon here, 1 carbon here, so that's an ethyl group. B comes before E. All right, so now I know what the 1's there. Now, I can put a 2 here, or I can put a 2 here. How do I know which way to put the 2? Well, there's nothing actually telling me which way to put the 2, but if we move over to 3, I can put it on the left, I can put it on the right. Here, I've hit another substituent. And I now have the lower possible number for my next substituent, which is actually the rule. We don't get a substituent here, but we do on the right. And so we're going to label around our molecule like this. You only have to worry about the second substituent. You don't have to worry about the third, fourth, fifth, sixth, or seventh. You want the lowest possible number on your second substituent, and then you've already set the direction of your ring, so there's nothing else you can do. All right, so now we've got our numbers. Now we're going to list and then put it all together. On number 1, and here's a hint, on cyclic compounds, there is always a number 1. Always, always a number 1. In fact, always the number 1, and you list that number 1 first because it's alphabetical, which is how you decided which way to do it in the first place. So this is going to be 1 bromo, and then over here on number 3, we had, I should list them here for my consistency. 3, we had an ethyl, and so it's going to be 1 bromo, 3 ethyl cyclopentane. And that's how you'd name that molecule. And that is how we name ring structures. All right, so just a couple more and then we'll be done. This one, we can do this one super quick. We're going to find the longest chain. 1, 2, 3, 4, and 5. I labeled it starting from the left because I knew I had this chloro over here, and that chloro would win alphabetically over my other methyl groups. And so I've got a pentane, nothing on number 1. On number 2, I've got a chloro. On number 2, I've also got a methyl. I'll circle that guy here. On number 3, there's nothing. On number 4, there's a methyl. And when I put those all together, I get 2 chloro, 2, 4 dimethyl, and then 5 was pentane. So I get 2 chloro, 2, 4 dimethyl pentane. Here's your chance to try to find the name of a molecule. So give yourself a moment, pause, look at that structure, and see what you can come up with your name. All right. It's very tempting on this one to do what we've always done and just go right across and say it's some sort of hexane, in which case you might have gotten either A or C. However, if we're a little bit more careful, we could do 1, 2, 3, 4, 5, 6, 7, and we would have found that it is actually some sort of heptane molecule. So even though we usually just go across that middle one, up, down, and it usually works, it doesn't always, and so you do have to explore all those other different possibilities as you're trying to name the molecule. And it doesn't matter whether we name it from the left to the right. We've got 3, 4, 5 trimethyl heptane, or B right there. Okay. And that is it. That was our naming of organic molecules. After this, what we're going to do is we're going to go backwards. We're going to say, how about if I give you a name, can we draw the molecule? And this one's a bit tedious. This one's a lot to learn, but you do learn it eventually and systematically. The other way, going from a name to a molecule, once you've learned how to do the naming, is so easy in comparison. So that's what we're going to do next. Thanks.